The base set of operators was presented together with variables. Here we show additional operators for manipulating bits and how to use pointers. Bitwise operators perform operations on bits in the variable. Among them, bitwise logic operator exists. It means the same logic function is applied to every pair of bits in two arguments. Bitwise, or logic function, represented by the vertical line called bar or pipe, means that if at least one bit is 1 at the chosen position, the resulting bit will also be 1. Bitwise end function, represented by ampersand sign, means that if at least one bit is 0, the resulting bit is 0. Bitwise logic operators shouldn't be confused with logic operators, represented by double pipe or double ampersand, which operate on a single Boolean logic value. Bitwise operators also allow data to be shifted left or right by a chosen number of bit positions. They are represented by double greater than or lower than signs. Shifting is often used in embedded programming to access the bit at a specific position. Shifting data one bit left results in multiplication by 2, while shifting one bit right results in division by 2. Variables are identified by their names in the source code. While translating a source program into machine code, the compiler assigns every variable, regardless of whether it's simple or complex, the individual address in the memory. Referring to a variable by its address can be done with a pointer. In other words, a pointer is a variable that holds the address of another variable. The size of the pointer is equivalent to the length of the memory address, depending on the processor class, usually 16, 32 or 64 bits. A pointer doesn't contain a value, but instead points to the variable in the memory where the value is stored. A pointer variable must be initialized with the address of operator and used to access the variable content with the dereferencing operator. The address of operator returns the address of the variable. Operator dereferences a variable, it provides access to a value that the pointer variable points to. We can use the asterisk symbol to define the pointer variable. After definition, the pointer doesn't hold any specific address. We can assign the pointer to a previously defined example variable. To get the address, we use the address of operator. From this point, the example pointer holds the address of the example variable. We must use the dereference operator to access the example's variable's value. The x variable will get the value of the example variable. Pointers allow the execution of the same code with different variables. Note that the variable we point to doesn't need to be a simple integer. It can be any variable like an array, structure, or other. Using a pointer is a method of passing bigger structures as arguments to functions. Instead of passing the whole array, we pass the pointer to it.